So this equation could be a function of x, and an equation or a function is even if you can replace every x with negative x and it doesn't change the result. So the classic even function that's always presented in textbooks is y equals x squared. In other words, f of x equals x squared. If you replace x with negative x, you still have to square it, right? And squaring a negative number is the same thing as the square of the positive version of the number. So if I plug in negative x, I get out the same thing. That's why this is an even function. So we can check to see if this one's even. We're going to replace this x with negative x. This equation is even. One second. Yeah, okay, so this equation or this function is even if plugging in negative x gives us the same thing as leaving the equation alone, not changing x. They're not the same, right? The only difference is this has a positive x, this has a negative x, but since there is one difference, not even. Okay, a function is odd if, odd, if f of negative x is the same thing as negating the entire function. In other words, multiplying the entire function by negative 1. So here is that negation. You multiply the entire outside of this function by negative 1. You can put a negative sign on the top. Okay? And so the question is this the same thing as this? And you might be wondering if there's some tricky algebra we can do. Well, you could rewrite to get the negative sign from down here up top. Look, I can factor out a negative 1 from the denominator. I messed up here. I've tried to factor out a negative 1. This should be a positive, right? Because I'm factoring a negative 1 out of both terms. So this should be a positive. Okay, so since this is not the same as this, because of that minus sign, that plus sign, then it's not odd. So this function is neither even nor odd. And there's a graphically, there's a quick way of checking. If they make a mirror image about the y-axis, like this parabola does, you know, if you could fold this like a piece of paper with the y-axis and it makes the same thing, then it's even. Okay? With odd, you have to make two folds. If a function is odd, you should be able to fold it on the y-axis and then fold it on the x-axis, or vice versa. So fold it like a piece of paper on the y-axis, and then fold it again across the x-axis, and it should make the same shape. And this one does. This is x to the third. Okay, x to the third is odd because if you plug in if you multiply the entire outside function by negative 1, you get negative x to the third. And if you were to plug in negative x, it's the same thing, right? Because negative x cubed is a negative x cubed. You can write the negative on the outside. It has a negative result. So this is an odd function, and it's odd. You could do a quick check graphically by folding it on the y-axis and then folding it on the x-axis, and it should make the same shape. Even, if you fold it just once on the y-axis and it makes the same shape, then it's even.